Sometimes I look up at the moon and wish I could just throw a lasso around it and pull it a little closer. But fortunately for everyone living on Earth, no one's made a lasso that's 384,000 kilometers long. That's roughly how far away the moon is from Earth. So other than gravity or the occasional lunar eclipse, it's hard to picture the Earth having an effect on its long-distance partner. But it turns out, the Earth is forcing chemical reactions to happen on the lunar surface. Our planet is making the moon rust. Now, when I say rust, I'm not talking about the flaky red stuff you can find on the underside of a 1983 Buick. It's still a kind of iron oxide, meaning it's made up of iron and oxygen atoms. But this lunar rust is actually a mineral that goes by the name hematite. And when hematite was discovered on the moon back in 2020, it caused a big stir. For one thing, hematite typically forms when a bunch of metallic iron comes into contact with liquid water and oxygen gas, neither of which, you may have noticed, the moon has in significant quantities. But on top of that, out of all those moon rocks the Apollo program brought back, scientists have never found any definitive evidence of oxidized iron. Now, for anyone who needs a chemistry refresher, an oxidized atom is one that's gotten one or more of its electrons snatched away by a different atom. In the case of iron oxide, the thief is, drumroll please, fluorine. Just kidding, it's oxygen. But why the lack of evidence? The moon's over 4 billion years old. Surely some iron oxidation took place. Well, maybe it did. But oxidation isn't a one-way process. It can be undone by giving the oxidized atom some new electrons to hang on to. It's called a reduction reaction. And as it turns out, the sun is a really great reducer. And by sun, I mean the solar wind, the constant but not always steady stream of charged particles the sun's blasting out into the greater solar system. Most of the particles in that wind are protons. And when a bunch of protons hit a bunch of hematite, they can destroy the crystals with a bunch of reduction reactions. Now, here on Earth, we're mostly protected from the solar wind by our strong magnetic field. Combine that with our atmosphere full of oxygen, and it means that rust forms pretty easily down here, and it sticks around too. But the moon's magnetic field is about as present as its atmosphere. Technically, there's a tiny bit of both, but they're so barely there, we often say that the moon doesn't have either of them. So not only is the moon lacking some pretty important ingredients for making its own rust, the solar wind that's constantly slamming into it is unmaking any rust that pops up. And yet, there's rust on the moon. So where's it coming from? If you read the title of this episode, you know the answer. It's us. Hi. But before I explain how we're the problem, it's us, say hi to this video's sponsor, Brilliant. Brilliant is an interactive online learning platform with thousands of lessons in science, computer science, and math. And when I say interactive, I mean they turn lessons into games. For example, the Science Puzzles course is full of 87 puzzles. They even have a puzzle called Blowing in the Wind, kind of like the solar wind I was just talking about. Then when you've completed all the science puzzles, you can do the classical mechanics puzzles, or the computer science puzzles, or logic puzzles, or any other puzzles offered on the site. There are tons to choose from. You can get started with your first 30 days free at brilliant.org/SciShow or the link in the description down below. That link also gives you 20% off an annual premium Brilliant subscription. Now back to a tougher puzzle. How the Earth is putting rust on the moon. The Earth is reaching out through the not-quite void of space and providing both a source of oxygen and a temporary safe haven to build up some of that hematite. You see, the magnetic field that protects our planet isn't a perfect sphere. As the solar wind runs into it, it gets deformed into a sort of windsock cone shape. And that long tail, the magnetotail, stretches all the way to the moon. So roughly every month for 5 whole days, the moon passes through it. And while it shields the moon from the solar wind, the magnetotail also flings charged particles from the Earth's upper atmosphere toward the lunar surface. I guess you could call it Earth wind, which is one classical element away from being an awesome band name. Back in 2017, a study published in Nature Astronomy estimated that tens of thousands of Earth-originating oxygen ions are implanted into the moon every second. In fact, the researchers behind the study also think that if you dug into the lunar surface, you could actually learn about Earth's ancient atmosphere based on the amount and type of oxygen that you find. Okay, That's a source of oxygen, but what about water? Well, when some of those solar wind protons hit the right kind of molecule, they can react to make good old H2O. But it turns out that might not be the only way. If you have an instrument like India's Chandrayaan-1 chilling out in lunar orbit, you can measure and compare water formation rates when the moon is either outside or inside of Earth's magnetotail. And according to a study published in 2023, which shared some of the same authors as the 2020 Hematite discovery, there's no decrease in water formation when the moon is shielded from the solar wind. So the team hypothesizes that the Earth isn't just shooting out oxygen ions to help the moon rust. A bunch of electrons are getting swept along for the ride too. And when they strike the lunar soil, they can cause chemical reactions that make water that can then go on to react with iron to make hematite. The Earth may be in a long-distance relationship with the moon, but thanks to a little help from our sun, we can send over a bunch of atom-sized presents to let our natural satellite know that we care. And that sounds pretty sweet, even to a guy like me, whose knowledge of chemistry is just a little bit rusty.